What's the true nature of the universe? To answer this question, humans come up with stories to describe the world. We test our stories and learn what to keep and what to throw away. But the more we learn, the more complicated and weird our stories become. Some of them so much so that it's really hard to know what they're actually about, like a napkin ring theory. The napkin ring problem involves finding the volume of a ring made from a spherical object. Essentially, when you cut a hole of a certain diameter in a sphere, you are left with a ring that resembles a napkin ring, that's the name. But the problem is if you take a napkin rings of multiple sizes but same heights, the volume of them will be always the same. And here is why.
First of all, let's call the height of the napkin ring h in the radius of a sphere capital R. Now a cross-section of a sphere like this and the cross-section of a cylinder like this are both circles. So their areas can be determined by using pi times the radius squared. So if we want to find the area of the sphere's cross-section and subtract the area of the cylinder cross-section, all we need to do is take pi multiplied by the radius of the sphere cross-section square and subtract p times the radius of the cylinder cross-section square. But what are the radii? Well, if this is the center of a sphere, we can draw a line straight up to the corner of the cylinder, down the side and then connect it to form a right triangle. This distance right here is the radius of a cylinder. So the Pythagorean theorem will help to find the length of the hypotenuse because it equals this length square plus the length of the other side square. So the radius of the cylinder square plus this length square equals the hypotenuse. It happens to be the radius of the sphere. So the radius of the cylinder will be equal to the square root of the radius of the sphere square minus half the height square. Now let's take a look at the area of a cross-section of the sphere. For this, let's draw a straight line from the center at the edge of the sphere cross-section. Let's call this distance a little r and notice this height y. So the radius of the sphere square plus y square equals the hypotenuse square. The radius of the sphere's cross-section will be equal in the square root of the radius of the sphere square minus y square. Anyway, let's take these two radii and plug them into our place. Finally, the result will be equals a negative pi times y square plus the pi times the height divided by 2 square.
The terms we're left with contains no mention of the sphere's radius. Whether the radius is large or small doesn't matter. All you need to know to find the area of the cross-section of a napkin ring is the height of it. Y, of course, is bounded by the height of the napkin ring. These blue areas have the same area as each other, and this will be true no matter where we cut the cross-section across the napkin ring, meaning both that napkin rings have the same volume.